So, good morning, friends. So, today we are going to discuss about overhanging beams. So, we will take an example and solve the problem on overhanging beam in this particular section. Now, this overhanging beams, as the name itself implies, if the length of the beam is extended beyond end supports, so it is called as overhanging beam. Now, here we have three types of overhanging beams. So in some cases, this overhang is provided only on the right side of the beam, and in some cases, its overhangs are provided only on left side of the beam. And finally, in some cases, these beams are provided with overhangs on both the sides. So beams having overhang at right hand side and beams having overhang at left hand side and beams having overhangs on both the sides. So this way the beams are classified into overhanging beams are classified into three different categories. So friends, see here this information is given regarding types of overhanging beams. So the first one, in the first case, this it is provided at the right side of the beam, and in second case, it is provided at the left side of the beam, and in third case, it is provided, overhangs are provided at both the sides of the beam. So generally, these overhangs, they are called as extensions beyond the length of the beam. So each beam will be having certain amount of length, and if the beam is extended beyond the length of the beam, then it is called as overhang beams. So here we have to use some notations for indicating the lengths of the beam and also for indicating overhanging positions, overhanging lengths of the beam. So generally, small l is used for indicating the total length of the beam, and small a to be used for indicating overhanging distance at one side. It can be either on left side of the beam or it can be on the right side of the beam. And similarly, if the beam is having two overhangs, letter A and B, both the letters are used for indicating these distances. So friends, L is used for representing the length of the beam as usual, L is used, small l is used for representing the length of the beam, and small a can be used for representing the overhang that is present at the left end of the beam. And similarly, small b can be used for indicating the overhang that is present on the right end of the beam. So if only one overhang is present in the beam, that has to be represented with small a. It can be either on a right side or left side of the beam. But if it is provided with two overhangs, then generally small a is used for indicating overhang that is present at the left side of the beam, and small b will be used for indicating the overhang that is present at the right side of the beam or right end of the beam. So this way we have to note down these terms: length of the beam, so that is very, very important, and the overhanging portions of the beam on the left side and right side and or right side of the beam. As usual, small l is used for indicating the length of the beam, and AB letters AB are used for indicating left and right overhangs of the beams. So friends, this is the, these are the things which we are supposed to know while discussing about these kind of beams. So as mentioned in the beginning of the slide, some beams are provided with one overhang at the right side. Some beams are provided with one overhang at the left side, and some beams they are provided with overhangs at both the sides. So if the length of the beam is extended beyond end supports, so generally these extensions they are referred to as overhangs, and therefore the that concerned beam, that particular beam, will be called as overhanging. So here we have to remember these notations: small l for indicating the length of the beam, and small a, small b for indicating overhanging portions of the beam. Now all these dimensions generally they are expressed either in terms of meters or in terms of centimeter or in terms of millimeters. So generally all the dimensions will be, given, will be expressed in the form of meters or will be expressed in the form of centimeters. Sometimes will be expressed in terms of millimeters. So as a whole, this OH beams, overhanging beams, are classified into three categories. First one with overhang at right side, and second one with overhang at left side, the last one with overhang at both the sides of the beam. So friends, here we are now going to take an example. We are going to solve a problem on overhanging beams. So here we can find three figures. First figure for indicating the loading diagram that will be given in the question. So using that loading diagram, we have to prepare equations, and we have to get the values of shear forces and bending moments at various points on the beam. And taking these values as usual, taking these values very easily, we can prepare the construction of shear force and bending moment diagrams. So friends, only loading diagram will be given in the question paper. So using the data that is given in the loading diagram, so we have to prepare equations, make calculations using these values. Ultimately, we have to prepare shear force and bending moment diagrams. Now, this is, here it is mentioned as a free body diagram. So generally, it is better to mention it as a loading diagram. So generally, these diagrams will indicate the various loads, acting on the beam. So here we have a point load at the right end of the beam, and we have one uniformly distributed load at the left end of the beam for a distance of 4 meters. So generally these diagrams are given for indicating various loads acting on the beam. So therefore, better it can be called as a loading diagram. So this will be given in the examination, and of course we have to make the construction of shear force and bending moment diagrams. So SFD for shear force diagram and BMD, so that is bending moment diagram. Now coming to this, arrangement. So that is given in the loading diagram. So this is an overhanging beam, provided. This is the beam which is provided with the overhanging portion at the right side of the beam. So friends, this beam is divided into, three portions. First portion is AB, and the second portion denoted by BC, and last and final portion, third portion, denoted by CD. So, as I've already told you, so the beam has to be divided into different portions, and we have to prepare SF and BM equations for each and every portion. So then only we can be in a position to get the values of shear forces and bending moments. And finally, we will be in a position to construct SF and BM diagrams. So friends, here the letter A is used for indicating the left end of the beam, and letter D is used for indicating the right end of the beam, and letter C for indicating the second support provided at this point of the beam. So supports are provided at point A and point C as shown in the figure. So we can actually see the arrows provided in upward direction. So supports are always they are represented with the help of arrows shown in upward direction. And now this can be called as the length of the beam. So one support is provided at point A, and another support is provided at point C. So therefore, this AC is used for representing the length of the beam. And finally, CD is used for representing the overhanging portion that is provided at the right hand side of the. So friends, small L has to be taken as 8 meters. So AC is given as 8 meters and CD is given as 2 meters. So in this problem, small L, length of the beam is given as 8 meters. That is, L is given as 8 meters. And one overhang, length of the only one overhang, it is given as 2 meters. So therefore, A is given as 2 meters. So length of the beam is given as 8 meters, denoted by small l, and overhanging distance, overhanging portion, so that is given as 2 meters, denoted by small a. So always the length of the beam is denoted by small l, and small a is used for indicating the overhanging portion of the beam that is provided at the right hand side of the. So friends, this is the way of identifying the various distances. And similarly, here coming to the loads acting on the beam. So a point load of 20 kilonewtons, it is acting at the right end of the beam, that is a point D, that is at point D, that is right end of the beam. A point load of 20 kilonewtons is acting at the right end of the beam, and an uniformly distributed load UDL of 10 kilonewton per newton, 10 kilonewton per meter, it is acting for a distance of 4 meters from the left side of the beam, or from the left end of the. So point load of 20 kilonewtons, it is acting on the right at the right end of the beam, and a uniformly distributed load of 10 kilonewton per meter, it is acting for a distance of 4 meters from the left end of the. So these are the important parameters. So this is the starting point of UDL, denoted by point A. Of course, it also indicates the left end of the beam. The end point of the UDL, it is denoted by point B. The distance is given as 4 meters. AB is given as 4 meters. BC is given as 4 meters. That means the distance between this point and the second support, that is given as 4 meters. And finally, the distance between the second support and the right end of the beam, that is given as 2 meters. So friends, the length of the beam must be taken as 8 meters, and overhanging distance, this overhanging portion, that is the distance of overhanging portion, the length of the overhanging portion must be taken as 2 meters. And finally, friends, a point load of 20 kilonewton, a point load is acting at the right end of the beam, and a uniformly distributed load is acting at the left end of the beam for a distance of 4 meters. So using this, information, now we have to prepare, equations for different portions. So beam is already divided into different portions, A, B, B, C, and C, D. Now we'll be starting at the right end of the beam and we'll be proceeding in reverse direction for reaching the left end of the beam. So therefore, firstly, CD portion will be considered for preparing equations. And secondly, BC portion will be considered for preparing equations. And finally, AB portion will be considered for preparing SF and BM equations. So all the information is given in this loading diagram. So indication of supports, arranged at point A and point C. The length of the beam is given in the diagram. The length of the overhanging portion is given in the diagram. The points at which supports are provided, point A and point C, that is shown in the diagram. A point load acting at the right hand side of the beam, that is shown in the diagram. And finally, UDL, that is acting at the left hand side of the beam for a distance of 4 meters, that is also shown in the diagram. So friends, using these distances, using these points, using the loads and all that, we have to, prepare SF and VM equations for different regions. So we have to begin with the CD region, CD portion, followed by BC portion, followed by AB portion. So separately in this particular order, starting from CD portion, we have to proceed in reverse direction for reaching AB portion. So we have to prepare SF and VM equations, and these equations will be very useful for making calculations and ultimately for preparing shear force and bending moment diagrams. So friends, every clear information is very wonderful. Clear information is given in the loading diagram. It's already divided into different portions, and the lengths of the portions are also clearly shown in the loading diagram. AB is given as 4 meter, BC is given as 4 meter, and CD is given as 2 meters. Now, therefore, using all these values and loads, values of loads, acting on the beam, so we have to prepare shear force and the bending moment equations. But before doing that, we have to measure the value of reaction forces. So reaction supports are provided at point A and point C. These supports will be, offering some kind of reactions against loads, acting on the beam. So they are called as reaction forces. So RA is used for indicating a reaction force offered at the point A, and RC is used for indicating reaction force offered at the point C. So therefore, friends, before starting the problem, we have to measure the values of RA and RC. Are very, very essential for framing SF and VM equations. So before starting the problem, we have to measure the values of RA and RC. So RA is used for indicating the reaction force offered by the support at point A of the beam, and RC is used for indicating the reaction force offered by the second support at point C of the. So friends, calculation of RA and RC values are very, very essential before starting the problem. So let us note down these calculations. So friends, before that, let us note down the data that is given in the problem. So point load of 20 kilonewtons. Point load of 20 kilonewtons is acting at the right end of the beam. So capital W is used for indicating point loads. So therefore, capital W, it is given as 20 kilonewtons so far as this problem is concerned. Now coming to UDL, UDLs are denoted by small w. It is given as 10 kilonewton per meter, and it is acting for a distance of 4 meters from the left end support or left end of the beam or left end support of the beam. So therefore, capital W has to be taken as 20 kilonewtons, small w to be taken as 10 kilonewtons per meter. So friends, always point loads are expressed in terms of newtons or kilonewtons. So in this problem, it is expressed in terms of kilonewtons. And UDLs will be expressed in terms of kilonewtons per meter. So capital W for indicating point loads and small w for indicating UDLs. And friends, so far as this problem is concerned, only one point load is acting at the right end of the beam, and one UDL is acting at the left end of the beam for a distance of 4 meters. So we will be considering only these two forces. So only these two loads will be considered for preparing shear force and the bending moment equations at various points or at various regions or portions of the beam. Friends, this data is also given in the problem. Length of the beam is given as 8 meter, and overhanging portion denoted by small a, that is given as 2 meters. Now it is split up into 3 portions, AB, BC and CD. So AB is given as 4 meters. So UDL is acting for a distance of AB, that is 4 meters. The BC is given as 4 meters, distance between UDL and the second support. Again, CD is given as 2 meters. There is distance between second support and the point load at the right end of the beam. And also supports are provided at point A and point C. So we have seen all these things in the figure provided in the previous slide. So friends, using all these values now, before starting the problem, using all these values, we have to measure reaction forces at point A and point C. So reaction force at point A simply called as RA, and reaction force at point C simply it is referred to as RC. So RA, RC values are very, very essential for solving the problem. So in the next slide, we'll be making the calculations of RA and RC. So friends, we can see this methodology to be used for making the calculations of RA and RC. So we have to use the conditions of equilibrium. Totally, we have 3 conditions. But here, these 2 conditions are sufficient for getting the values of RA and RC. So sigma V is equivalent to 0. That is the first condition. Sigma M is equivalent to 0. That's the second condition which is required, which are required for making these calculations. Now we are using the first condition, sigma V is equivalent to 0. But implies sum of upward forces will be equivalent to sum of downward forces. RA and RC are acting in upward direction. Reaction forces are provided in upward direction. So loads are acting in downward direction. So reaction forces written on the left hand side of the equation. Upward forces written on the left hand side of the equation. Downward forces written on the right hand side of the equation. So RA plus RC. So it is equivalent to 20. So this point load is acting in downward direction. It is written as 20. Now UDL is acting for a distance of 4 meters. UDL of 10 kilonewton per meter, that is acting for a distance of 4 meters. So you have to multiply these two terms for converting UDL into point load for making calculations. So it is written as 10 into 4. So by totally RA plus RC, it is given as 60 kilonewtons. So friends, using the first condition of the equilibrium, using the first equation, so we are getting a relation between RA and RC. And now we have to use the second relation, sigma m is equivalent to 0. It implies sum of anti-clockwise movements will be equivalent to sum of clockwise movements. So if these values are equal to these values, then only sigma m will be equivalent to 0. So sigma m is equal to 0. It implies that sum of these anti-clockwise movements will be automatically equivalent to sum of clockwise movements. So we are taking moments about point A. So therefore, this will become anti-clockwise moment. And the moments because of these loads will become clockwise. So this is written on the left hand side of the equation and this is written on the right hand side of the equation. So RC, this is acting at a distance of 8 meters from point A as shown in the figure. It is written as RC into 8. And UDL is 10 into 4. It is becoming 40. And that will be acting at a midpoint of total distance, that is 4 meters. That is, it will be acting at a distance of 2 meters from point A. So 40 is multiplied with 2. And this point load of 20 is acting at a distance of 10 meters from point A. It is written as 20 into 10. So friends, making all these calculations, 8 RC will be 280 and RC will be coming to 35 kilonewtons. And substitute the value of RC in this equation, 60 minus 35, we get the value of RA. So RA is given as 35 kilonewtons. So using the data, using the distances given in the loading diagram, using all the loads given in the loading diagram, using the conditions of equilibrium, first and second conditions. So we have to frame the equations and we have to get the values of RA and RC. So friends, without calculating the values of RA and RC, we cannot think of starting the problem. So before starting the problem, measurement of RA and RC values are very, very essential before starting the problem. And we have done all these calculations in this particular slide. So now friends, we are coming to the second slide. Now we have to prepare, as told in previous sessions, we have to prepare SF and BM equations for different portions. The beam is as shown in the loading diagram. The beam is already divided into 3 portions, AB, BC and CD. But we have to start from the last portion and proceed in reverse direction. And we'll be reaching the first portion. So this is the last portion shown in the diagram. So therefore now we have to prepare shear force and bending moment equations for the last portion of the beam, that is referred to as CD portion. Now in any case, secondly, in any case we have to consider a section XX at a distance of X meter from point D, that is the last point of the beam, and we have to fix the limits of X values. So friends, for CD portion, lower limit automatically, naturally, it will be equal to 0 meter. And upper limit, the total length of CD portion is 2 meters. So therefore, upper limit has to be fixed as 2 meters. So friends, considering a section and considering lower and fixing lower and upper limits for portion is very, very essential for preparing shear force and bending moment equations. Now, using this, information, we can easily prepare shear force and bending moment equations. So, friends, for CD portion, SF, it is obtained as 20 kilonewton. 20 kilonewton is only one load. We have to consider all the forces that is present on the right hand side of the section. So here only one load is available at the right hand side of the section, that is acting in downward direction. The magnitude is 20, so it is written as 20 kilonewtons. Downward forces to be provided with a positive symbol, so therefore SF is written as 20 kilonewtons. Now, friends, for this corresponding value of SF, we have to prepare corresponding bending moment equation. So it is obtained by taking the product of force and perpendicular distance. Force is equivalent to 20 kilonewtons and perpendicular distance already it is taken as x meter, so it becomes 20x. Now the load is acting in downward direction, it will result in clockwise movement. So negative symbol must be allotted for clockwise movement. So therefore, friends, it is written as minus 20x. So friends, these are the equations, SF and BM equations so far as the CD portion is concerned. SF is equivalent to plus 20, that is SF equation, and BM is equivalent to minus 20x, that is the BM equation for this particular portion or for this particular region of the. Now friends, finally we have fixed the limits of X, lower limit as 0 and upper limit as 2 meters. And substitute the values of the values of X, these values of X in this equation. We get two sets of shear force values and also, two sets of bending moment values. So here, friends, this equation is independent of this x parameter. So therefore, at this point, SF will be equivalent to 20, and at this point also, it will be equivalent to 20. Whereas coming to the bending moment diagram, at this point, it will be equivalent to 0. 20 into 0, you will be getting 0. And at this point, that is this moment will be equivalent to 20 into 2, that is it will be coming to 40. Of course, a negative sign will be there. So at both the points, SF is plus 20 kilonewtons. But here, so far as bending moment is concerned, at first point it will be equivalent to 0, and at second point it will be equivalent to minus 40 kilonewton. So friends, this is the way of preparing, this is the way of considering section, this is the way of fixing the limits. So considering section, fixing the limits, framing the equations, and taking the limits of X and getting the values, substituting the limits in these equations for getting the values of SF and BM. So these things are very, very important for making calculations in all the portions of the beam. So friends, these are the values so far as CD portion is friends, as I've already told you, we have to proceed in a reverse direction. So secondly, we are selecting BC portion. Again, we are considering a section XX, again at a distance of X meter from point D of the beam. And here we have to consider, just like any other portion, just like all portions, just like any other portion, we have to consider all the forces present acting on the right hand side of the. So therefore, this rule has to be adopted while preparing equations in all the portions. Now, friends, we have to fix the limits for x values. Here, lower limit must be taken as 2 meters. The distance between D and C, that is given as 2 meters. So therefore, it has to be taken as 2 meters. And the distance between D and B, that is given as 2 plus 4, that is 6 meters. So lower limit has to be taken as 2 meter and upper limit has to be taken as 6 meter. So far as this particular portion is concerned. So friends, now we are going to prepare we have to prepare, using this information, we have to prepare SF and EM equations. So for preparing these equations, we have to consider all the forces that is acting at the right hand side of the section. So friends, these are the forces which we come across at the right hand side of this particular section taken in this BC portion. So 20 is acting in downward direction, you are putting plus 20, and 35 reaction force at point C, that is acting in upward direction. Negative symbol has to be allotted for upward forces and a positive symbol to be allotted for downward forces. So therefore it is written as plus 20 and minus 35. So it will be coming to minus 15 kilonewtons. And again, this equation is totally free of x value. So therefore, at x is equivalent to 2, at this point, this will be equivalent to minus 15 kilonewtons. At the upper limit also, the value of SF will be equivalent to minus 15 kilonewtons. Now friends, similarly, we have to prepare a bending moment equation. So bending moment equation, it is generally obtained by taking the product of force and perpendicular distance. So take the individual forces and corresponding perpendicular distances. So it is written as 20x. So this is at a distance of x meter from point D. It is written as 20x. Now this is written as a 35 into x minus 2 because this support is provided at a distance of x minus 2 meters. Total distance is x meter, and this is acting at a distance of support is acting at a distance of 2 meter from point D. So therefore it is written as x minus 2. Now this downward force is resulting in clockwise movement, so you are putting negative symbol. The upward force is resulting in anti-clockwise movement, you are putting a positive symbol. So friends, bending moment equation, it is written as minus 20x plus 35 into x minus 2. Now you substitute the values of lower and higher values of x in these equations. So the first value of a bending moment will be equivalent to minus 40. So minus 20 into 2 plus 35 into 2 minus 2, that is 0. So it will be coming to minus 40. And again take the value of x and put it in this equation. So it is 20 into x minus 120 plus 35 into 6 minus 2, that is 35 into 4. That will be coming to 140. 140 minus 120, it will be coming to plus 20 kilonewton meter. So friends, we got the values of shear forces and we got the values of bending moments. So these are the calculations so far as the BC portion is concerned. Now friends, additionally we have to make some calculations. Now here bending moment is a changing sign in this portion. So it is changing from minus 40 plus 20 2, it is changing, the magnitude from minus 40 to plus 20 kilonewton meter. So it is changing the sign in this region. So we have to locate the point at which bending moment is equivalent to 0. So unless it becomes 0, it cannot change sign from positive to negative or negative to positive. So therefore, we have to locate the point at which bending moment is 0. Now for doing this, we have to equate this the corresponding above bending moment equation to 0. So equating this, equation to 0. So we have to find out the value of x. So by doing all these calculations, x will be, obtained as 4.67 meters. So this distance will be, this 4.767 meters will be from point D. So therefore, friends, bending moment will be 0 at a distance of 4.67 meters from point D, and this is called as a point of contraflexion. So friends, indicating the points of contraflexion is also very, very important after preparing this bending moment diagrams. So using these rules, we have to find out the values of x. We have to find out the value of x. So that will be at a certain distance from point D. So in this case, it is at a distance of 4.67 meters from point D. So at this point, the value of bending moment will be equivalent to 0 so far as this problem is concerned. And the point at which the bending moment is 0, this is called as a point of contraflexion. So this point is called as a point of contraflexion, and we have to indicate this point also after preparing the bending moment diagram. So friends, we are coming to the last portion, that is the AB portion. Now here also, as usual, we have to consider a section at a x meter from point D, and you take all the forces that is acting at the right hand side of this particular section. You have to consider a section at a distance of x meter from point D. You consider all the forces present at the right hand side of this section. So therefore, SF, this will be useful for preparing SF and BM equations. So using these forces, SF will be equivalent to 20 minus 35 plus 10 into x minus 6. So friends, 20 is acting in downward direction. You are putting plus a symbol. 35 is reaction force acting in upward direction. You are putting minus a symbol. And now this coming to this UDL. So this UDL is 10 kilonewton per meter. So it has to be taken for a distance of x minus 6 meter only. Total distance is x, and we have to remove 6 meters from that total distance. Then only you will be getting the distance for UDL. So therefore, it is written as x minus 6. So friends, the SF equation is ultimately it is written as 20 minus 35 plus 10 into x minus 6 expressed in terms of kilonewtons. Now we are fixing the limits for this portion. Lower limit that is fixed as 6 meter, and upper limit is fixed as 10 meter. That means point B, it is at a distance of 6 meter from point D. So therefore, lower limit is taken as 6 meter. And point A, it is at a distance of 10 meters from point D. So therefore, upper limit is taken as 10 meters. Now you substitute these values in this equation. So at this point, SF will be given as minus 15 kilonewtons. And at the second point, SF will be obtained as plus 25 kilonewtons. So friends, this is the way of framing SF equation and fixing the limits and getting the values of SF. getting SF values for AB portion. And similarly, now we have to prepare bending moment equation. Now for doing this, as usual, you take all these forces and multiply these forces with corresponding distances. This is acting, this will be at a distance of x meter. From point, it's written as 20x. And this is at a distance of x minus 2 meters. So therefore, it is written as 35 into x minus 2. And this force is it is converted after getting converted into point load. It is given as 10 into x minus 6. Now at the middle of this distance, this will be acting as a point load. So therefore, the distance is taken as x minus 6 by 2. It is taken as half of this distance, that is x minus 6 by 2. So this way, friends, we are getting bending moment equation. So this is acting in downward direction, resulting in clockwise moment. So we are putting minus symbol. This is acting, this force is acting in upward direction. It will be resulting in anti-clockwise moment. We are putting plus symbol. And again, UDL is acting in downward direction. It will result in again in clockwise moment. You are putting minus symbol. So minus symbol, plus symbol, and again minus symbol. Minus symbols for clockwise movements and plus symbol for anti-clockwise movements. Now, friends, take the values, limits of x values, that is x meter, 6 meter and 10 meter. You take the lower limit and get the first value, substitute the values, these values in this equation. So first value will be given as plus 20 kilonewton meter. And second value will be obtained as 0 kilonewton meter. So friends, considering a section and taking forces at all the forces at the right hand side of the section, fixing the limits for each and every portion, preparing SF and BM equations, and substituting the limits of x in these equations, and getting the values of shear forces and bending moments. So these things to be done not only for this portion, but for all the portions present in all the things given in all the problems. So friends, we have come to the last stage. We have done it for the first portion. We have done it for the second portion. Again, here we have done it for the last portion, that is called as AB region. And friends, now here we have to make some additional calculations. This shear force is a changing sign. It is changing from negative value to positive value. So therefore, the for doing this, changing the sign, it will be becoming 0. So therefore, we have to locate the point at which the SF is equivalent to 0. So equate this SF equation to 0. So automatically you will be getting that point, and it is measured as 7.5 meters. So therefore, friends, SF will be equivalent to 0 at a distance of 7.5 meters from point D, or at a distance of 2.5 meters from point A. So friends, this point also has to be indicated in SF diagram. So in the earlier slide, we got a point at which bending moment is equivalent to 0. That has to be shown in bending moment diagram. And here we got a point at which shear force is equivalent to 0. So therefore, we have to indicate this point on SF diagram. So that point to be indicate, that point at which bending moment is 0 to be indicated at the bending moment diagram. This point at which SF is equivalent to 0 to be indicated at SF diagram. So friends, measure a distance of 7.5 meters from point D in reverse direction. you will be certainly getting the point at which SF will be equivalent to 0. So friends, indicating these points are very, very essential on SF and VM diagrams. And finally, friends, at this point, that means at the point at which SF is equivalent to 0, bending moment will be equivalent to maximum. So we have to find out additionally, we have to make additional calculations. Additionally, we have to find out the maximum value of bending moment. So if you don't find out the maximum value of bending moment, we cannot prepare, we cannot complete the diagram. So at the point where SF is equivalent to 0, so bending moment will be equivalent to maximum. So bending moment will be having maximum value. So friends, substitute the value, take the value of X as a 7.5 and substitute this value in this particular equation. So automatically we'll be getting the value of maximum bending moment called as BM max. So BM max, so it will be equivalent to minus 20 into 7.5 plus 35 into 7.5 minus 2, that is 3.5 plus 10 into this much. So therefore it will be coming to 1.125. So simply take the value of X as 7.5 and substitute in this particular equation. Automatically you will be getting the maximum value of bending moment. So friends, it is obtained as 31.25 kilonewton meter. So friends, for this problem, for this arrangement, the value of bending moment will be maximum, and that will be equivalent to 31.25. And friends, this maximum value will be falling in this region, So therefore, it has to be shown in this particular region only. So with this, we have completed the calculations so far as all the portions of the beam are concerned. Now, friends, as usual, take the values of SM and BM, take SF values and BM values at all portions. Construct these diagrams, SF diagrams and BM diagrams. Take all the values of shear force and bending moment of all the portions and prepare SF diagram. Take all the values of bending moments at all the portions, prepare bending moment diagrams. Now indicate the points of contraflexion. I have already told you in the previous slides. Also indicate the value of BM max, maximum bending moment in this particular diagram. So as informed just now, it will be falling in AB region. So indicate the point of contraflexion in obtained in BC region and maximum BM obtained AB region. And similarly, indicate the point at which is SF is equivalent to 0 in SF diagram. So friends, in SF diagram, we have to indicate these such points properly in SF diagrams. And in BM diagrams, we have to indicate values of maximum bending moments, and also we have to indicate the points of contraflexion. So this is the way of making the calculations. So friends, as far as such problems are concerned, we have to find out the values of RA and RB. So then we have to prepare equations for different portions. We have to fix limits for different portions. We have to make calculations. We'll be getting SF and BM values. Apart from that, sometimes we have to measure these points, measure the points at which SF is equivalent to 0, and also have to measure the points at which bending moment is equivalent to 0. And also we have to indicate the point at which bending moment will be equivalent to maximum. So by taking this condition, so that and all we have seen in the previous slides. So friends, thank you all for watching the session. Now we are closing this session.